Okay, this represents our discussion very well. Here we have the pressure distribution showed. If you have such a tank, if you have such a tank and it's filled with water and mercury, you can see that it creates a free surface on top, and this free surface um, is exposed to the atmosphere. So the pressure we have above this, above the water, is atmospheric pressure. So here you see the pressure distribution starts from atmospheric pressure, and as you go down it increases with increase in H. So here we see that as you go down, as the depth increases, or as you go down vertically, you have pressure increasing. And we can also see that point A, B, C, D, E, F, G, H, and J represent the pressure direction at those points, and you can see that they are always perpendicular to, you can see here that it's perpendicular to the surface. You can see for B that it's perpendicular to the surface, and for C and D you can see that the direction, or the arrow, is perpendicular to the tangent for the curve. You can see for E, F, G, also H and I at the bottom. You can see H here at the bottom. So the pressure acts perpendicular to the surface. Pressure acts perpendicular. So three things to take from here. If you have a free surface of a fluid that is exposed to the atmosphere, on the surface you will have atmospheric pressure. As you go down, as the depth increases, you will have pressure increasing, and pressure always acts perpendicular to the surface of the container, or perpendicular to the wall. Another thing that we need to take from here is the discussion shown at the bottom. It says that pressure at point A, so you can see the discussion here, pressure at point A, B, C, D, E, F, and G are equal. And this is because the position is it is horizontal, and it can be connected by a horizontal line, and pressure does not vary as you move along the horizontal. And you can also see that even if it's acting on different surface, it is independent of the surface, and it is equal. It's not dependent on its horizontal position. And you can also see that the fluid you have in A, B, C, D, E, F, and G is water. So the fluid did not change, so the pressure will not change. And you can also see that the pressure at these points is equal to P atmosphere plus rho GH, plus rho GH. So you have that pressure being constant for A, B, C, D, E, F, and G. But for the case of H and I, these are not equal to the above pressures, because for H you have a different fluid. You have a different fluid, but not only a different fluid, but also a different depth. So the depth you have at D and E is somewhere here, and the depth you have for H is somewhere here. So you have an increase in H, so the pressure is expected to increase. But not only that, you also have another fluid, mercury, here. So the pressure will be different from that of A, B, C, D, E, F, and G. And for I, you have a variation in H, in the depths. So there is increase in the depths from the previous location, so you have variation in pressure. But still you can see that the fluid is the same for I. So another takeaway point is, as the fluid changes, the pressure will change because the density is changing, and as the depths change again, pressure changes.